All right, let's do this. Hello, everybody. Welcome to the third episode of Hack Summer. My name is Taggart. You can find me at Twitter at mttaggart. And what we're doing here on Hack Summer is we are going over Python, and through Python, we're going to be learning the basics of cybersecurity. If this is your first time, welcome. If you're a return viewer, welcome back. Thank you for coming back. Really appreciate it. So the last time we were together, we were exploring conditionals and loops, and we learned a little bit about brute force attacks on passwords and dictionary attacks on passwords, and we used word lists to crack simple passwords, as well as created a password generator that allowed us to use kind of a pre-made alphabet and choose randomly from it to create a strong password, or a sort of strong password, right? We limited its length for the cracking purposes, but the same code could be used to extend that and create a stronger password generator. So we've gone over two of the four core structures in programming so far. The first one was variables, right? Where we store information for later use. The second one was, we've done three. We've done variables, we've done conditionals, where we change the flow of our program based on different conditions, testing for whether a condition is true or false, and depending on whether it's true or false, executing different code. And then we did loops. We have one more structure to do before we finish up the four core data structures, and I've been kind of keeping that one under the behind the curtain because it's so important and I care about it so much. So we're going to be doing that next time. So we're going to take a break from the core data structures, and we're going to talk about specific data types today. And we've done a whole bunch of data types already, right? We've done strings, we've done integers, we've done floating point numbers. But what we need to do next is a kind of data type, or a class of data type in Python called sequences. And sequences we've seen before, and actually we use them in our loops. Sequences are data types that can be looped over. They're also called iterables, things that we can iterate through, that we can do repeated processes on. And really conveniently in Python, there are some very common, amongst all types of sequences, there are common syntax and methods that we use to work with these sequences. So we're going to go over them today, and in doing so, we're going to get into some really cool cryptography going all the way back to like the 2nd century BC or BCE. So I'm really excited. Let's get started without any further ado. We have a lot to cover, and it's all pretty exciting. So let's get to coding. All right. So if you're just joining us for the first time, we use replit, or repl.it as our coding interface. And I'm logged in this time just to save us a little bit of time. If you haven't done this before, you can sign up for an account. Pretty simple to do so. And we're going to just create a new REPL here to play around with some sequencing. We'll make a new Python REPL, and we'll just call it SEQS. You can call it whatever you want. All right. Now, as I said, we've already seen sequences, and we've seen them in the form of strings, right? And just as a reminder, let's create a string here, right? Let's just call it MSG or message, and let's say hello world, right? Very, very simple. And we can confirm that this is a sequence by looping over it. So if you remember, when we have something that we want to loop over, or put another way, we know how many times we want to repeat our loop, we use a for loop. So we're going to do for, and let's just say C for character in MSG. And that tells Python, okay, do the following code for every element of the message. we're going to just print it, right? Print C. And this tiny little variable here is called an iterator, just as a reminder, because it's keeping track of the current thing, the current element in the sequence that we're looping through. That could be a number, it could be a substring of the big string that we're working through. But that's what we're using when we refer to the iterator. It's this tiny variable here. So let's go ahead and click run. So 1 character per line, including the space, we get each character in turn of our string. So this tells us that that message and strings are sequences. And what that means is that we have a few other tools that we can use with them. And I want us to get real comfortable with these concepts because we're going to be seeing them again and again as we work with strings and other kinds of sequences. So I'm coming over to the right-hand side of my code window here, and I'm going to just confirm that I have the MSG variable in my interpreter because I ran the code, so that variable should be loaded into memory. And indeed I do. And I just checked by typing MSG and pressing enter. I'm going to zoom that in just a little bit so it's a little bit easier to read. Okay. Now, obviously through this loop, we saw that we can access subcomponents, smaller parts of that big string. Well, what if I want to do it not in a loop, but I just want to access them manually? I can do that using a syntax called indexing. And let's talk about indexing just for a second, because it can get a little bit confusing. Let's start by demonstrating the syntax. So let's say I wanted to get the first character of this string hello world. What I'm going to do is type out the variable name MSG, right? And then I'm going to use square brackets, that's next to the P key on an American keyboard anyway. And I'm going to put in the number, which is the index of the character that I want out of the string. Or abstracted out for all sequences, I want to get the element of the sequence. So I want the first character of hello world. And because this is computer science, we start counting at 0. I'm going to put in 0, close my square brackets, press enter, and I get back H. If I ask for the first one, I'm going to get E. That's indexing. Just to drive this home, I want to just kind of demonstrate this here. I like to think of indices as addresses on a street, right? So if we look at this string, I have all of these characters in sequence, and I can, and then I need more space for the 10, 11, 12, but you can see how each of these characters corresponds to a specific address. And that's it. That's all that indexing is. We have a couple of other cool tools here. One of them is len. There's a built-in function in Python called len, which will take a sequence and tell you how long it is, how many elements it has. So len, and then inside of its parentheses, so it works just like print. We give it the variable, or we can use a plain old string, right? So if I put just a string hack summer in there, that works too. And it gives me back the length of the sequence. Really, really handy, especially if we want the loop to run based on numbers rather than the specific characters. Okay, let's clear the screen here. And okay, I still have that in memory. The next trick that we need to learn with sequences is something called slicing. And as you might expect from the term, slicing allows us to take slices, bits of the string or the sequence, and it allows us to do it in a bunch of different ways. So let's say that I wanted just hello without anything else? Well, I'm going to use something like the same syntax that we did for indexing, where I did square brackets, and then inside of these square brackets, I'm going to start with the index of the slice, where the index where I want the slice to start. So I want it to start at the beginning, so that would be 0. Then I put a colon. And then I tell Python where I want the index where I want the slice to end. And this is going to be non-inclusive. So if I want just hello without that comma, I'm going to say 5. And then square brackets. And then press enter. And then I get myself just hello without anything else. One of the things that often happens in strings is we want the last character or the last element of a sequence. And when you can slice like this, that makes it really, really easy in Python, because Python has a cool trick. It can index backwards. So I can actually use MSG and -1, and that'll give me back the exclamation point from the end of the string. So that also works, I'm pretty sure, unless I'm misremembering. I can do like MSG 0 to -1. Yeah, and notice that because the end of the slice is non-inclusive, it takes off that exclamation point. So I can kind of mix forward and backward there when I'm doing slicing. Something also that comes up pretty frequently is skip counting. So let's say you wanted every other character or every other item in a sequence. You can do that. So you can do what's called an interval. So let's say I wanted to go every other, to capture every other item in the string. So I can say 0 to -1 would take off the last character. I don't want to do that. I can actually just leave the second number empty. And in fact, I can even leave the first number empty because it's 0. But if I say, if I want to go, so this is, I want to get everything. If I just did this, notice it gives me the whole string. But if I say after the second colon, if I say go by 2s, you can kind of see what's going on there, right? It's going from H skipping, right? And then skipping again, and then skipping again. And then, so that's kind of how we're going through it. This also works with negatives. So if I wanted to reverse a string, this is actually a pretty quick way to do it. All right. So we have done our first bit of Python code here today. We have created a little bit of indexing magic here. And what we're going to do next is actually do our first proper program. But before we do, we have some things that we need to talk about. All right, so let's talk about cryptography. Cryptography is the art of creating and deciphering codes, right? Encrypted information. And there are a lot of different variants on this word with crypt in front of it for secret. And I want to go over them very quickly just so we understand what we're talking about when you hear these different kinds of, when you hear these different terms. So cryptography is the art of doing this. It's the craft of creating these codes. Cryptology is a little bit different. Cryptology is the study of it, right? It's the academic pursuit relating to cryptography. And then finally, perhaps most excitingly, is cryptanalysis. And cryptanalysis is when you're actually trying to analyze codes and decipher them. So that's sort of, what you would have going on in the NSA, right? If they're listening in for signals intelligence, or any other kind of intelligence community. I want to, as we're talking about cryptanalysis, I want to shout out a really cool book that I hope all of you get a chance to read, which is Code Girls by Liza Mundy. This is the story of the women who during World War II were instrumental in deciphering German and Japanese codes so that American forces, Allied forces, were able to intercept those transmissions, decipher them, and use them to win the war. Now, Alan Turing and the group in Great Britain that were deciphering the Enigma codes get a lot of coverage and are well recorded in history. But it turns out that the American, kind of women who went to college, especially, had as important a role in this cryptanalysis effort, and their story is finally getting told. A lot of them weren't able to tell their story because they were under that information was classified for so long, and even after that, the women were, for fear of betraying a national secret, weren't unwilling to tell the story. Finally, they were able to do so, 70 plus years later. And so if you have a chance to read this book, I highly recommend it. What we're going to do next is we're going to create an ancient cipher. And it's so ancient, it goes back to the Roman Empire. It goes back to Julius Caesar. Now, cryptography is that old. In fact, it's older. One of the oldest pieces of cryptography that we have is something called a skytale. A skytale dates back to ancient Greece. We're not sure exactly when skytales were originally introduced, but we have history going back as far as the 4th century BCE of their reference, and then the 2nd century BCE of their use for keeping secrets. And by the way, if you go into escape rooms ever, you'll find skytales a lot in escape rooms, so it's kind of a cool thing to know about how they work. So essentially, a skytale is a strip of paper or leather that has letters written on it. And if you have the correct diameter rod, you wrap the leather strap around the rod, and if you've aligned it correctly, you'll get a message. So that's one of the wanted to call out one of the first bits of cryptography that we have records of. So we're going to be doing a slightly newer, by a few hundred years, version of cryptography called the Caesar cipher. And you've absolutely seen this before, even if you didn't know it. So a Caesar cipher is an alphabet substitution, right? So you have your alphabet, and what we do is we shift the alphabet forward or backward a given number of spaces, and then the resulting message is going to look different because different letters are in that place. So if you know what the shift is, you can decipher the message. It's not super secure. It's easy enough to guess even if you're brute forcing it, but it's a great introduction to how we begin the encryption process. All right, so we're going to create a Caesar cipher right now. Abbiamos, which is Latin for let's go. Alrighty, so let's go ahead and make a new REPL. Choose Python, and we'll call it Caesar. All right. So, just as a reminder, if you have any questions, feel free to put them in the chat. I'll do my best to answer them in real time. Before we jump into code, let's think about the plan here. What do we want to do? So we want to have an alphabet and a message, and then shift the letters in the message by X number of spaces, and then print the result. I find it very helpful, just as a good programming practice, to comment out what our steps are going to be. Clarify your thinking before you jump into the code. If you can state the problem in plain English or any other language, you will definitely order your code more quickly, and you'll be able to think through the problem more clearly if you can do that. Writing, by its very nature, orders our thinking, and so I think it's a good intermediate step between just kind of the idea and jumping into code. All right, so we know that we're going to need an alphabet. Let's go ahead and make one, and because it's going to be a constant, we're going to all caps this variable. Alphabet equals that looks right. Wonderful. And we're going to just do lowercase for today. That's fine. Okay. And then we're going to have a message. The message is going to be Hack Summer. A couple of things to notice about this message. First of all, it's all lowercase, and that's just for ease right now. We can absolutely handle other kinds of cases, right? We can write that code, but just to keep it simple for this demonstration, we're going to keep it all lowercase. The other thing to notice is that there are some characters in this message that are not in our alphabet. That's okay too. We can create code that handles those and just sends them right into the encrypted message without transforming them. And then we're going to begin our encrypted message as an empty string. Because what we're going to do is we're going to add onto it, as we've seen before with string concatenation. Now, it's important to call out before we go any further that this would not work unless strings were sequences, because we're going to be indexing alphabet and we're going to be indexing message. Okay, so if you think about the next steps, we have to go through each character in the message and transform it, right, into our encrypted message. We have to go through each character. Whenever you hear the word each when you're talking through it, or every, right, that's a key that you're going to be using a for loop, and indeed we are. So we're going to go for C in message, right, again for car or character. And let's just go ahead and print C. We'll just do this, just this much to confirm that our code is working as expected, right? So we're getting access to the message, and we are getting every character in turn. Cool. Now we have to match up. The letter here with the position in the alphabet. I forgot one really important variable, didn't I? I forgot the shift. So the shift number, how many letters we're going to shift it down. Let's just do 8 for now, which is a classic Caesar cipher. Okay, so what that would mean is that an A turns into 1, 2, 3, 4, 5, 6, 7, 8, because it should turn into a J. Okay. The first thing we want to do is actually use a built-in method for sequences called find. Check this out. So I should have alphabet over here. Yep. So alphabet has a built-in method. And we've seen some of these before. If we put a dot after it, we get access to all of the things that the item can do. And this one is find. So if I give find a substring, like the capital A, it'll actually tell me what the index is. Now, -1 means that it couldn't find anything. So if I give it a lowercase a, it'll tell me that it found it at 0. And B tells me that it found it at 1. So this is a real, first of all, dot notation, super important concept, and we'll be revisiting it again and again. It's how we access all of the things, all the characteristics and abilities of the objects that we have in our code. But for now, we're going to stick with find. And we need to find whatever the index is of the letter in the alphabet, because we need to shift it by shift amount. So we're going to start with a IDX, which is a pretty common abbreviation for index, equals alphabet that should be all caps, right? Alphabet.find, and we're going to look for the character in question, which is C. Okay. Now, astute programmers might notice that we already have some potentials for bugs in here, right? What are we going to do about the spaces? What are we going to do about the exclamation points? We're not checking to see if they're in them, in the alphabet. That is true, and that is by design. We're going to do that after we see the error, because I want to see the error first and then fix it. Okay. Now we're going to just go ahead and shift it real simply. So we're going to say new IDX equals IDX plus shift, right? So whatever the letters, the new letters index is going to be that. Okay, and then we're going to say encrypted plus equals, right? That shortcut for adding to an existing sequence or existing variable value, which in this case would be string concatenation plus equals. We're going to do alphabet with the new IDX. So you see we're using that indexing, right, with our square brackets, and we're using the variable new IDX to get at it. Okay, and then at the very end of this, we're just going to go ahead and print encrypted. All right. Who thinks we're good here? I'll give, if anyone wants to call out things that they think are problematic with our code, I'm going to give you a couple of seconds to do that. All right, well, let's run it and see what happens. Yeah. String index out of range. We have a problem. Let's take S, right? So S, we have alphabet, right? So alphabet dot find lowercase s is 18. Adding 8 to it is 26, but the last index in our string is 25. Right? There are 26 letters, so if we start at 0, the last index is 25. So we have a problem, because if we are adding 8, we're going to be out of range. Well, that's no good. So we have to account for that. We have to kind of loop around back to the beginning. There's some tricky ways of doing this that are pretty cool. We're going to do it a pretty simple way. It's not the best way to do it, but it's the way that uses what we've already got covered. Okay, so what we have to do is we have to check. We have to have a safety check here to see if that's true. So what we're going to do is check if new IDX is greater than the len of alphabet -1. We're going to do that safety check. And if it is, we're going to, actually, let's do it the other way. Let's check if it's less than, right? So if everything's good, do things as we've described. Why do we have to do this -1? Okay, so what we want to make sure is that the new index, whatever that new index is less than 25, right? Our last index. The length of the string alphabet is 26, right? This is a count. It doesn't start at 0, it's just counting. So we say, okay, if we just said if it's less than 26, that's no good, because we actually want it to be less than 20, less than or equal to, actually no, len, sorry, I overthought it myself. So actually this will work fine, because len alphabet will work if it's less than 26. That's fine. Okay, so if it is less than 26, we're good. We don't have to do anything else. But if it is not, if it's more than 26, we have to do something else. We have to kind of loop it around. And the way that we're going to do that is we're going to kind of say encrypted plus equals, and then we're gonna do this a little bit differently. So we're gonna do alphabet, and then we're gonna do some math inside of this indexing. So we're gonna do new IDX minus the length of alphabet. Now we could have just written 26 in there, but what if your alphabet is a different length? So we're going to do it this way. So basically we're saying, subtract it and then use the index that is the difference between these, right? So we know that this number is greater than 26 or equal to 26 if we got here. And so we are subtracting alphabet from it, and that loops us back to the beginning of the alphabet by however many spaces. Let's try that. Okay, so it kind of works, but we are missing our spaces and our exclamation point, and we want to have that. We have another cool trick, which is we have find, which returns the index, but we actually have another structure that we can use to find out if something is in a sequence, and that's the keyword in. So I can say something like capital A in alphabet, and that'll return false because the capital A is not in alphabet. But if I do A in alphabet, I don't know why I did single quotes for that, but that returns true. What that means is we can use that in an if statement. So what we're going to do is we're going to actually wrap all of our existing code inside of another if statement. We're going to say if C in alphabet. So if it's even in there, do all of this stuff. By the way, I did a control and right square bracket to indent all of that stuff. And then if it's not, notice Replic's giving us these helpful little indentation lines to tell us where we are in our code. So if the character's in the alphabet, cool, we can do all this stuff. If it's not, what do? We're just going to add the character. We're just going to pass it right through. So encrypted plus equals C. Yep, pixacumes. And that's our Caesar cipher. And you can change the shift, it still works, right? A very common shift is called a rote 13, where we rotate it by 13. Works fine. All right, so we have ourselves a working Caesar cipher. Before we go into our next part, I want to talk about where we're going. The next piece of programming that we're going to do requires a new data type called lists. I love lists. Lists allow us, kind of like strings, but with different kinds of data, to store multiple pieces of information in a single variable. And they are sequences. We can loop over them. We can index them. But they're a little bit more flexible than strings. Lists are really cool. When we put elements into lists, we can use any data type. We can use strings, we can use integers, we can use booleans. We can even put other lists inside of them. And you'll see how that works in just a minute. We're going to explore lists briefly, and then we're going to do some cool stuff with lists, including, if we have time, making a book cipher. So let's get right to it. All right, let's go ahead and make a new REPL, and we'll just call it list demo. And we're going to learn about lists very, very, very quickly. So over here, we're going to create our first list. And I'm going to make a list for ships. So ships equals, and then we're going to use empty brackets. So empty brackets don't just index, they also create empty lists. They indicate lists. Now we can put stuff inside of it if we want. Let's actually do that. Let's start with obviously the Starship Enterprise gets in there. And let's add one more just so we can see how this goes. So another ship, let's say Voyager. Cool. Now, ships has two elements, Enterprise and Voyager. If I ask for the len of ships, it gives me 2. I can index it just like we did before. If I do ships 1 gives me Voyager, ships 0 gives me Enterprise. All right. What if we want to, once we've created the list, how do we change it? Well, the first thing we can do is use the append method. And before we go any further, and since we're talking about dot notation, I want to call out the importance of looking at the documentation for Python. We haven't explored it yet, but it's really, really important. You want to go to docs.python.org. You want to get real familiar with this site because this is your Bible when you're learning how to program. Any language's documentation is really, really important. And in particular, for right now, you might want to take a look at the library reference. This is kind of the standard library of modules in Python and built-in types. And you can see that there's a section for sequence types here, including list tuples, which we haven't talked about yet, and ranges. So if we look at this, you can see some of what we've already done, right? The slicing, the indexing, in, not in. And there's a lot of great information here about how to work with these. So really, really important here. And append is what we're going to talk about now. So append is how we add elements to lists after we've created the list in the first place. So if I want to add another ship, let's say Excelsior. So if I do ships.append Excelsior, and I ask for ships, now there are 3. You might have noticed that there's also a pop in there. Pop is really handy because it pops off and returns the last item, or you can put an index in there, but by default it's the last item in the list. So if we do ships.pop, that'll return Excelsior, and if I ask for ships now, it's not in there anymore. Let's go ahead and put it back. And then if I do ships.pop and give it an index, notice that it gives me Voyager now. So if I ask for ships, there it is. Okay. Append, pop. We've done len, we've done in. You can also concatenate lists, just like we do concatenation of strings. So let's say I had, we have ships, let's plus equals. I can't say like plus equals, I'm trying to think of another one, discovery. That is not exactly what I wanted to have happen, right? You can see that that didn't really work. That's no good. So I want to clear that out. There we go. So del is short for delete, and if you give it your list and then a slice, well, if you give it a slice using a given list, it'll take out the slice that you want. So that's how we got rid of all of the letters of discovery in one go. Was we said we're going to start at index 2, 0, 1, 2, and then just go, and it deleted the rest of that for us. So we have, we can do list concatenation, but we can't do it this way. Instead, we would have to actually make this a tiny little list first. right? So now we're taking two lists and putting them together. And now if I ask for ships, now I have 3 elements in my list. Okay. There is, before we go and do our first piece of code with lists, there is another kind of sequence that you saw in the documentation called tuples. Tuples are defined very much like lists, but with parentheses. And the difference really between lists and tuples is that tuples are not changeable once you make them. So if I say, they're often used for coordinates. So if I say like coordinates equals like 1, 3, and I try to say, I can get the y coordinate, say, or the x coordinate. So we go coord 0. That'll give me, I can index them. I can even slice them if I want. -1 works. But if I were to say like coords.pop, that won't work because tuples can't do that. So just know that tuples are used when you have sequences that you never want to change after you make them. All right, how are we doing on time? 10:41. Cool. What we're going to do now is we're going to create a very, very simple piece of code that will collect factors. So a little bit of math here, right? So we're going to loop through a bunch of numbers, and given the base that we're looking for, if a number is divisible by that, if it's a factor of it, then we are going to add it to our list. To do that, we have to make use of a mathematical operator we haven't seen yet, which is the modulo. So the modulo is really, really cool. It's represented by the percent sign, and what the modulo does is it does integer division and gives us the remainder. So if I do 10 mod 2, there's no remainder when I do 10 divided by 2, right? It divides straight. But if I do 10 mod 3, right, we know that there's a remainder of 1. So this is really, really helpful for checking divisibility, obviously, because at least by integers, right? If it's if whatever you're moduloing returns 0, then it's divisible by that. So let's just create some factors here. Let's do, say, our base, what we're going to be checking, base num. Let's look for factors of 7. And then we're going to go up to, let's say, 1,000. And then we're going to create a list that stores our factors. Okay. This is where we're going to loop over a range, as we saw last time. So we're going to say for I in range max num, right? Which is going to go from 0 up to, but not including, the max number of 1,000. If I wanted to include 1,000, I could do max num plus 1. And if I wanted to start at 1 so that I'm not trying to divide by 0, I can do 1 comma, and that tells me where the start is and the stop. So I'm just going to check for divisibility here. If I mod 7 equals, or sorry, I mod base num equals 0, factors dot append I. So we're taking that factors list, right? And we are appending the number to it that we're testing if it's divisible by the base number. And we'll just go ahead and print the factors. That looks pretty good. These look like they're divisible by 7. Nice and clean. Nice and clean. But you can see how we're adding to our list, and we're using the list to store this information. And then we can do other things with it once it's stored in our code. This is really why lists are so important. They allow us to store and process information very efficiently in our code. All right. I think we have enough time to do this next piece, so we're going to jump into it. Okay, our last exercise for today is another really old bit of cryptography called a book cipher. Book ciphers have been used by spies for a long, I guess as long as books have existed and been commonly available. We don't have a date exactly on the first book cipher, but they've been around, and they've been around in popular culture. I think the first time I ever saw a book cipher was in the movie the original movie Mission Impossible, where they used the Bible, and Bible codes are really, really common. A book cipher is, let's say you and I want to exchange secret messages. You and I both have the same book, the same edition of the book, so that all of the pages are right and the word counts are the same. So the code then is about choosing a page and then maybe a paragraph and then a word or something like that, or just a page and the word. And then that's the encryption, and then there may be some other pieces to it, but the basic idea is that book is how you look up the words that you're referencing. Dictionary cipher is very, very common. If you both have the same edition of a dictionary, right, you can choose like a page and the entry in the dictionary. So we're going to do that. We're going to do that with a specific book, and I'm going to make sure that I put the URL to that up here for you. And you can do this with any book you want. If you want to play along exactly with us, then feel free to do that and get the book that we're using. But all right, without further ado, let's go ahead and make our book code. So, all right, let's transition over to code time. All right, go ahead and make a new REPL here, and let's call it book cipher. Now, we're going to do something really, really interesting in this one, because we're going to split our code. For this one, we're going to have main.py, and as we've said before, that's always what REPL runs by default, and that's fine, but we actually want to take some of our code out of main.py, and we're going to put it elsewhere. So the first thing that we're going to do is make a new file, and let's call it bookcipher.py. And inside of this, we're going to put, this is going to be where we load the book and create chapters. Because it's not a physical book, right? We can't do pages necessarily, or we could, but it would be difficult. Instead, what we're going to do is we're going to do chapter headings, and we're going to split up the book by chapter. The book that we're going to use is public domain. Feel free, this right here, I'll put it in chat too, is a bit.ly link. It leads to a text file that I've shared out, which is Moby Dick. And I'm going to upload that file right now. You can try to open it, but it's gigantic. It's like 1.2 megabytes, so I'd rather you didn't. Instead, we're just going to play around with it kind of as a black box. Okay. The first thing we need to do is open the file, and we've seen that before. We're going to save it as in a variable. We'll call it text equals. Got to finish my comment first. There we go. Text equals, and then we're going to open, and then mobydick.txt. Okay. And then we're going to get the lines. Every line equals text.readlines. Make sure you have the empty parentheses after that. And what this is going to look like is every line of the text file, okay? So it's going to be a lot of text. If you were to just like for line in lines print line, or if you wanted to loop through all the lines and print them, it would be a lot. So you can do that if you want. I recommend not doing that. You could, if you want to print lines 0 or something like that using indexing, you could do say print lines 0. And in fact, if we click run, this won't do anything. Why? Because it's in bookcipher py dot not main.py. If we wanted to have main run it, we can do this from bookcipher import asterisk, or import bookcipher works too, but there's a reason we're doing it this way. And look, code ran. You can see that we get chapter 1 loomings, right? That's the first line in the text file. The reason this works is it's looking in the folder for another Python file that has this name. Notice I don't have quotes around it, and then it runs whatever code because we haven't wrapped this in anything that would prevent it. So it just imports it and cold runs it that way. Okay, so we've confirmed that we're getting text out of the book. What we want to do is we actually want to split this book up into chapters. What we want to have, our code is going to look, the code is going to look like a tuple, where the first number in the tuple is the chapter, and then the second number in the tuple is the word. Okay, so that's going to be kind of how the code goes, is a tuples of chapter word. That's how the book cipher is going to work. To do that, I need to split this book into chapters because right now it's just a bunch of lines. Well, how do I do that? Turns out that in this text file, very handily, every chapter starts with this all caps word chapter, and that doesn't happen anywhere else in the text. So I can use that to sense in my code when a new chapter is occurring and split up the list of chapters accordingly. Remember that I said that our lists can contain other lists. So what we're going to do is we're going to make a list of chapters, but the list of chapters itself is going to contain lists of words. Like so. Chapters equals an empty list. And so every element in the chapters list is going to be a chapter. But what is a chapter? A chapter is going to be a list of words. I don't want lines. I want words because we have to count words. So I have to split those lines up. To do that, I need another list. So I have an empty list, and the first thing I'm going to put in that empty list is another empty list. If I do something like that, so let's just say test, I'll call it nested, and I do a list like this, 0, 1, 2. If I ask for nested 0, it gives me that first element, right? Which is this list of 0, 1, 2. Can I index from there? Yes, I can. If I ask for nested 0 and then again I index to say 1, I'm going to get back this number 1. So I can do these nested lists, and I can also do nested indexing. Super important for what we're about to do. Okay. To do this right, we have to keep track of what chapter we're currently on. So we're going to make a quick variable here called current chapter, and we're going to initialize it to 0. That's where we start. Now, I need to be counting. I can't just get the line. I need to know what number line I'm on, what index line I'm on, as I go through all the lines in this. Because of that, I have to not loop through. I can't do for line in lines. That's not going to work because I don't want the text straight away. I want the number. I want the index. So to do that, I'm going to do for I in range. Remember range. And then what's the range? Well, the range is the length of the lines. If I can type an L, len lines. There we go. It's 10:55. We're probably going to go a couple of minutes over, but I hope you can stick around. It's definitely going to be worth it to create our book cipher here. And if you can't, that's okay. Obviously, it's recorded. Feel free to watch at your leisure. And if you're enjoying the video, let me just also ask if you wouldn't mind hitting that thumbs up and clicking subscribe. That would be a huge help as well. So we're looping over all of the lines that we've pulled out of this text file. If we were to print the I, we'd get every single line in turn, or we'd get the number, right? So I actually do want the line as well. I want to do line equals lines and the specific line at that given index that we have from I. But I don't want it raw. I don't want it raw because at the end of every line there's this this new line character, which is represented with \n. Right? Look, it doesn't print anything, but see how it went down a line? So there's one of those at the end of every line, and I don't want that because I don't want it as part of my list of words. So to remove it, I can use the .strip method. Remember that dot notation. We're accessing the things that the string can do, and we're using strip. That takes out line breaks from the beginning and end of the white space as well from the beginning and end of the string. So we're stripping the unnecessary characters off the beginning and end of the line. That's good news. So we're just getting the actual text. And then we need to do one more thing. I need to take this string, right, that whatever the line is, and I need to split it up. I need to split it up so that each word is its own element in a list. Good news, there is a split method on strings, and it takes the delimiter, whatever we're going to use to separate it out. In this case, it's just going to be a space. And that gives me a list of the words. So I'm going to go ahead and make a variable for that. Say words equals line dot split with the space. Now that's going to include things like periods and punctuation. That's going to be part of some of the words, but for our purposes, that's totally fine. That doesn't really matter. There are handy replacement methods as well that we can use to clean up the text even further, but this is fine. Okay, so now we have a list of words from every line, right? And what we want to do is we want to add those, that list of words, we want to add those to the current chapter's list of words. But we also want to check for chapterness, right? Let's go ahead and just add the list of words to the existing chapter. So let's say chapters, we won't do the chapter check yet. So what chapter do we want to add to? We want to add to the current chapter, whatever that is. So we're going to access the list at index current chapter, whatever that is. So chapters, current chapter. What are we adding to it? This is where thinking about data types really, really matters. What am I adding? I'm adding words. What is words? Well, we know that when we do split, we get a list. So we have a list, and we're adding a list to it. We're trying to combine those two things. That's list concatenation. So we can use the plus. So plus equals words. Okay. That works as long as it's still the same chapter that we want. But what if it's a new chapter? We have to add another chapter to our list of chapters, right? We have to add one. Well, first of all, how do we check to see if it's a new chapter? We know that there's going to be this all caps chapter thing. So that's what we're going to do. We're going to check for that. If all caps chapter in words, remember that in keyword, so we're just say, hey, is this in your list of words? If it is, turns out you've got yourself a new chapter. What we're going to do is we're going to increment that current chapter counter, first and foremost. And then we're going to, rather than add to the existing list, we're going to append to the outer list, right? We're going to add a new list up here, which is just words, right? Because we have to add another one of these internal lists, which is what we're going to do with append. So we'll say chapters.append words. And then our original code for adding to the chapters looks like this. I know that's a lot, but this is kind of cool. We've taken care of loading the book and getting it ready to make the code. So let's go ahead and click run here. Now, I haven't printed anything out, but the code did run, and to confirm it, let's just go ahead and look at our chapters. Let's go look at chapters 0. This is going to be a lot of text, right? That's too much. Let's go ahead and go chapters 0 and 0. Right, we have kind of all this stuff here, this Unicode stuff, but then we have the word chapter for the first word. Now, what's the second one, right? 2 Loomings, then space, call me Ishmael. Famous first words of Moby Dick. So we have ourselves a book loaded by chapter, by word. We're ready to go. In main.py, we're going to actually make our book code. Okay, so we've gone ahead and imported the book cipher code, which means that we have access to the chapters variable right away. We don't have to redo any of that. We can just access chapters from here. Now, we're going to start with creating a cipher as an empty list. Because what is our cipher going to look like? Our cipher, remember, is going to look like it's going to look like a list of tuples, and each tuple is going to be the chapter and word number that relates to our book. So cipher equals empty list. And now we're going to have a message. How about I love whales? I guarantee you we can make that message with Moby Dick. Now, you have to be careful, right? Because if you choose a word that doesn't exist in the book, right, something's going to go wrong, and we'll actually include that error checking in our code. Okay, this is going to require a lot of looping, but nested looping, which isn't always the greatest programming practice, but I think it's a great thing to see, at least for now. The first thing we need to do is loop through the message, right? We're going to look for this word in the chapters. And so we have to start, the top level thing that we need to loop through is the message. So we'll say and I'm going to use M in message. We can print M, first of all, just to keep track of what we're doing over in our output. And then we're going to, and this is a pattern I often use in programming, is I like to have a little flag variable, a true or false, a Boolean that we keep track of and lets us determine whether or not we have succeeded. So I'm going to use found M as my variable, and I'm going to initialize it to false. Remember that capital F, because I haven't found the word yet. I haven't found the word in the book. I'm flipping through it. I haven't found it yet. And this is, we're simulating flipping through the pages of a book to find the thing. Okay, well, now we need to go through each chapter, right? And then in each chapter, we need to go to see if the word exists. So the next loop that we need to nest inside here is for we're gonna use I because it's an iterator. It's going to be a raw number in range len chapters. Why am I doing that? Why am I not just looping through the chapters? Because I don't want the chapter list just yet. I will inside the loop, but I actually really want that index, because that index, that I, is going to be what ends up going into this chapter value, whatever that is. So I need this I because I have to keep track of it. Okay, so we're going to be looking through all of that. What is this yelling at me? Unexpected EOF. Okay. Now we need the chapter. We're going to say chapter equals chapters, and then we're going to access it with that index. That totally works. Now, Replic's yelling at me because it thinks that chapters may be undefined, but notice it says or defined from imports book cipher, which it is. So don't worry about that green line if you get it. Okay, so we have our chapter. Now it's time to loop through all the words in the chapter. And we're going to do O. I like to go I-O, P if I'm doing nested loops, just because they're next to each other on the keyboard. So for O in, same thing. Range, len, and what is it? So you'd also say call this words if you want, right? Rather than chap. That might be clearer. So for O in range len words. And then we can say word singular equals words of index O. So again, we're looping through every chapter. We're getting the list of words. We're looping through the all of the indices, right, of that length, and we're getting each individual word, and we're going to see if we find the word. So we're going chapter by chapter, word by word. Now, we have to test. If the word is equal to the M, right, the word in the message that we're looking for. Oh, by the way, we should probably split this, right, into the actual words, right, rather than have the raw string. Otherwise, it's going to be looking for I space L and then O, V, E. So we want to split it into a list of words, just like that. So if the word matches the word that we're looking for, we're going to say, first of all, we're going to flip that switch, found M equals true, and then we can stop looping. So we're going to break, but before we break, we actually want to do the work of appending what we found to our cipher. So this is where we do cipher.append. And what are we appending? Well, here comes that tuple, right? So a second set of parentheses. The first element in this tuple is going to be the chapter number. What is the chapter number? It's I, right? Whatever the I is, that's the chapter we're in. And then we need the word number, which is going to be O. That's why we did it that way, to keep track of those numbers. And then we break out of that. Now we've only broken out of the this inner loop here. So you might want to out in this level, right? After that for loop is done, say if found M equals true. By the way, you can shortcut this by saying just if found M, because that evaluates to true or false. So if found M, what we're doing in this one is a little bit different though, because we're not going to break. Because out here, right, we're looking through. We're no longer looping through the words in the chapter. Oh, sorry. Actually, yeah, we are. So if found M, break, and then we do one more. We check it out here, and this is why it's really important. So, out at this top, we're out in this top loop where we're looping through all of the words in the message. if we found it, then we can stop looking through the book for the word. We're done for that word, but we're not done with the loop. We have to look through for each word. So for this one, we're also going to check if found M, but then we're going to flip that switch again. We're going to say, okay, next word. We haven't found the next word yet. And then we're going to use the keyword continue. Continue is cool. So continue, it doesn't stop the loop. It just skips to the next thing that you're looping over. So if I was on I, right, and then I found it, it would be like, okay, we're done with looking for I. We can stop looking through the chapters. We can stop looking through the words. Now we're going to go over to love, and we're going to start the whole process over again, looking through each chapter, looking for each word for the word love. If we find it, the same thing's going to happen. We kick back over to Wales. If that isn't true, though, right? Otherwise, if we go through, if we go through all these internal loops, right, for each word, if we get to the end of looking through the whole book, which is right here, this is looking through the whole book. If we get through all of this, and that never happened, if found M, if that switch was never flipped, we have to handle that. We have to say, hey, can't make message with this book. And then break out at the top loop, right? Because let's say the first word is something we know we can't find, right? Well, then that's it. We're done. At the very end of all of this, we're going to print our cipher. Okay, everything looks pretty good. Let's see what happens. Check that out. We have I love Wales. 029, 02095, 2525. So we know that. And by the way, let's see if it confirms. So if I do chapters, right, and 0, and then look for word 29, what is it? I. Okay, what about 2095? Love. And wow, it takes until chapter 2, by the way, in Moby Dick, or chapter 3 in Moby Dick to use the word whales. Kind of interesting, but there it is. So look at how many nested loops we have. We have 3 nested loops. And please pay attention to your indentation as we're doing this. Really, really matters. Your code will not behave as expected if your indentation is not correct. Or it'll just error out. All right, well, we have finished up. I know we ran a little bit long today. That seems to be happening. I'm a little bit overambitious about what we're getting up to, but it's too much fun to stop. So I hope you were able to stick with us or just watch on your own time. But we have finished with the book cipher, but I do have a little bit of homework for you. So we do have this, this message that if you want to try to create a decoder program or use the chapters as loaded in the REPL as we just did to try to decode it, here's a secret message for you. If you go ahead and try to decode it, you'll get the secret message, and some of those tuples might look familiar. Okay, so that about does it for today. Before we get out of here, though, again, if you're enjoying this series and you feel like giving back a little bit, I encourage you, please, to donate, not to me, but to an organization that is trying to bridge the digital divide, just like we're trying to do here by giving this information to as many people as want it. That organization is Human IT. They are giving low-cost internet connections and computing devices to people and families who need them. You can find them at human-i-t.org. You can contribute financially, or if you have old technology, you can also donate it to them. Next week, we're going to complete our journey through the 4 core structures of programming with my favorite of the 4, functions. Thank you so much for joining us here at Hack Summer. Have a great week. Stay safe, stay healthy, and I'll see you next time.